Hi, this is again a subsequent class of the previous class. We will continue with subnetting. Subnetting is the process of borrowing bits from the host bits in order to divide the larger network into small subnets. Subnetting does not give you more hosts, but actually costs you hosts. You lose two host IP addresses for each subnet, one for the subnet IP address and one for the subnet broadcast IP address. In older technology, you would have lost the first subnet, as the subnet IP address is the same as the network IP address. Before subnetting, in any network or subnet, we cannot use all the IP addresses for host addresses. We lose two addresses for every network. The base network mask for class A is 255.0.0.0, or you can say /8. It means first 8 bits are reserved for the network and the rest 24 bits are reserved for the host. The base network mask for class B is 255.255.0.0, or you can say /16. It means first 16 bits are reserved for the network and the rest 16 bits are reserved for the host. The base network mask for class C is 255.255.255.0, or you can say /24. It means first 24 bits are reserved for the network and the rest 8 bits are reserved for the host. When dealing with subnet masks in the real world, we are free in most cases to use any type of subnet mask in order to meet our needs. If, for example, we require one network which can contain up to 254 computers, then a Class C network is fine, but if we need more, then we might consider a Class B network. Let's understand the subnetting concept. All computers here have been configured with the default Class C subnet mask, 255.255.255.0. Because of the subnet mask we used, all these computers are part of the one network. This also means that any one of these hosts can communicate with each other. If we now wanted to partition this network into smaller segments, then we would need to change the subnet mask appropriately so we can get the desired result. Let's say we needed to change the subnet mask from /24 to /27 on each configured host. We have just created 8 networks from the one large network we had. I am keeping things simple for now and showing only 4 of these smaller networks because I want you to understand the concept of subnetting and see how important the subnet mask is. Now each network has 32 IP addresses, where 30 IP addresses can be assigned to the host. Here are a few more examples. The network address 172.16.0.0 has a /16 base network mask. However, using the subnetting method, it can have network mask /24. There are 4 major elements to be considered when talking about subnetting. Network address of the subnet, first IP address of the subnet, last IP address of the subnet, and network mask of the subnet. Generally, when someone says, "What is the subnet mask of the IP address 192.168.1.1?" the person won't tell you the CIDR value. It is mandatory to consider the base network mask of the subnet. In our case, the base network mask is 255.255.255.0 because this IP address belongs to the Class C. If the IP address belongs to the Class A, the base network mask will be 255.0.0.0, and if the IP address belongs to the Class B, the base network mask will be 255.255.0.0. Let's take one more example. Here the host IP address 172.16.3.50. An administrator has given an indication that the IP address network mask is /24. If we do not consider the subnetting method, the base network mask will be 255.255.0.0 or /16. And the network ID will be 172.16.0.0. First usable IP address of the subnet will be 172.16.0.1. Last usable IP address of the subnet will be 172.16.255.254. The network mask of the subnet will be 172.16.255.255. If we consider the subnetting method, the base network mask will be 255.255.255.0 or /24. And the network ID will be 172.16.3.0. First usable IP address of the subnet will be 172.16.3.1. Last usable IP address of the subnet will be 172.16.3.254. The network mask of the subnet will be 172.16.3.255. Let's understand how we calculate the number of hosts per subnet. Here the host IP address 192.168.1.1, an administrator has given an indication that the IP address network mask is /24. Well, it is a Class C IP address. According to /24 CIDR, the subnet mask is 255.255.255.0. We got enough information from the administrator. We all know the IP address length is 32 bits long. According to our IP address, it has 24 bits reserved for the network portion, and 8 bits are free for the host portion. Now the exponentiation of 2 to the power of 8 is 256. It means we have a total 256 IP addresses in our bucket. However, all the IP addresses cannot be assigned to host devices. We need to remove 2 IP addresses from the total count, one is for network address and one is for broadcast address. Always remember, the first IP address of any subnet is reserved for network IP address and last IP address is reserved for broadcast address. Which means for us, the IP address 192.168.1.0 is a network IP address. The IP address 192.168.1.255 is a broadcast IP address. The range 1 to 254 IP addresses can be assigned to any network device. I have taken another example of Class B for you, and I will pause the video for a while and you can check the details. Also, there is some information that you need to fill in to check whether you understood the subnetting method. See you in the next lecture. Bye.